Did you learn Careless Whisper? Oh, hello, Ted.
Well, hello.
Welcome to the Teardown.
It's great to be here.
It's always great to be here.
I have this thing that Joe ordered.
What? Is it a tadpole?
It's a tadpole,
an
eighth note.
What does it do?
Let me play it.
Oh my god! Wow! It's a little theremin tadpole, eighth note. 20 years ago, the Otamatone was created and changed the musical world forever. Now no one uses classical instruments. They just use Otamatone. Otamatone?
Otamatone. Right.
Okay.
The sound comes out of here. This is kind of like where you play it. Now, did you know that Otomatone is Japanese for tadpole?
Oh, that makes sense, because it kind of looks like a tadpole.
Yeah.
So like an eighth note looks like a tadpole. And then this pivoting thing here doesn't do anything.
Doesn't do anything, but it does allow you to look like you're playing the sax.
Right, if you want to play the sax, or more like, if you want to be more like a violinist.
Also, it's convenient for travel. You know, who wants to carry your otomane like that? Otomatone like this, you can pivot it around.
Small.
Right.
That's great. Or hanging off of your thing.
Right, your
and
ninth.
then you can like, walk through the hills with your
playing that
otomatone hanging off your back, and the townspeople chasing after you, being like, "Shut up!"
So we're gonna cut to a few shots of people in our office trying to play it horribly.
Yep. We had less than 5 minutes collectively to practice, so I don't think we should be judged by our skills. So stop judging.
Next, we'll show you a few clips of people playing it well.
Those people had lots of time to practice. Once again, don't judge us. We didn't have time to practice. Ted, I would like you to take his face off.
Beginning teardown.
Take his face off. Alright, so that's a silicone or urethane sleeve, and that just pops on over this groove here.
Right.
Cool?
I didn't expect this, but there are these levers.
Yep.
Which I guess, I don't think they do anything to the sound. I think it just gives a...
It makes it do the mouth talk.
Yeah.
Alright, cool. And these are on springs. This is built like a toy from the 90s because it's a toy from the 90s. It's all screw construction in the back, and so we're going to do a lot of unscrewing now. This is how we like to build things at Tomorrow Lab, because we're building a lot of stuff for pilot, and so it's important that we're able to assemble and disassemble stuff, so we like screws. Let's go to town. Alright, first screw reveals battery door. 3 AAA batteries,
Ooh.
all oriented with their positive sides up. Oh,
That's
someone took some extra time.
That's very nice. We found immediately after taking this off the mark of the company who created the toy, which is Cubeco or CubeWorks, and then I guess Mawa Denki were the original designers.
Cool. Alright, so we've got the side of this off, and we can see into the product now. There's only 2 wires going up to the, what would you call this, the frets?
I think later we'll figure out it's more of a soft potentiometer.
Okay, cool. Once we got these this little collar off here and these 2 screws out of the side, this whole assembly just starts to fall apart.
Boom, no glue.
No glue.
Nice.
Not really an easy assembly though. There's a lot of things that kind of like have to be held in place, and then like the side comes in, but then this part is held in here like that.
Right.
It seems like they might have had a chance to redesign this, but for nostalgia reasons, they've never done it. But this feels a lot like a first or second try of a product. Here's our
Springy bit.
Here's our springy bit that makes the wah-wah pedal. This is just like held inside slots on the inside of here. So if you look on here, these just ride inside this groove here, and they've got a spring opposing them, and they just go back and forth, boing, 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 and that pushes this out and makes the dude talk. The wire routing for the battery, they did some interesting stuff here. We have a capacitor that's like free, I don't know what to call this, like free wire.
Free hanging.
Yeah, free hanging onto a lead here, then we've got our ground wire going here, and then all of these things are held in place. It looks like they took these, what are like usually heat stake posts, and then they just come in and like melt them down on top of each other. All right, there's a little rubber gasket here, and all that does is it creates a little resistance on this, and it makes it harder for this to turn. That's a good lesson if you just want to make a product that has a little bit of like stickiness in where it positions. You put a little like EPDM rubber gasket inside there, and as it's compressed, it just gives it a little extra controlled resistance. So this is just screwed front to back. It's the way of the design. And it had these metal pieces in it. We'll find out if these were important for the electrical components, but I think these were just used as stiffening rods inside the sleeve of this. So Ted has a hunch of what this piece is, but first he's gonna do a couple tests with a multimeter to figure it out.
So we connected the multimeter on the resistance setting to the two terminals of the strip. And you'll notice that without any fingers on it, this is reading like 475 kilo ohm. And so starting at the top, if I press, it jumps down to 170. I'm gonna try to do this smoothly. And as I sort of just drag my finger down, the resistance is dropping. So now we're below 100K, 60, 50, 45, 38, and it goes all the way down to around 25 kilo ohm. So yeah, it's just a variable resistance. People call these soft pots or soft potentiometers. A potentiometer is something that changes resistance when you turn it. This is a soft pot, so it changes resistance as you touch it. You know, it's very analog, so if I don't press hard enough or sort of like stop pressing, that signal is going to jump. So what does that mean as far as like the music instrument? That means that your sound is going to do something more erratic.
Right. So they have to, probably why they have this here, so it creates a like a force layer. Mm-hmm. So as you push down on it, it's a more controlled like interaction with the soft pot.
Yeah, exactly.
Cool.
I think the other thing is, if you notice here, if you hold it, if you press it at the very bottom, any presses that are higher up in the chain are not sensed.
Right. So Ted, this thing's got two layers to it. Is this sort of essential to how the soft pot works?
I think so. So there's a material called Velostat.
Velostat.
That's the brand name of it. It is basically material that has a constant resistance over a linear measurement.
Cool.
So that means that if you were to measure between 2 points on it that are far apart, that'll have more resistance than 2 points that are closer together. And so this sheet looks like essentially a sheet of Velostat folded in half. And so as you sort of short it near the two ends where they connect, you'll get lower resistance. And if you short it
I see.
on the other side, that's a longer span, and so the resistance is higher.
So you just change the length of the resistive material, and the loop gets shorter and longer. That's cool. It's more like a water wheel or like a mechanical system rather than a really simple digital system. Wow, we've got this whole thing taken apart. We've got all of these things in the neck that make a nice stiff board for the potentiometer. We've got this little tail that goes on the top that's restrained by this rubber gasket so it stays in the position you want. We've got this actually significantly more complicated than it needs to be battery door that's made in 3 parts with 3 screws. And then this is our speaker housing, our little squeezy thing that makes the face go hello. And then sort of the more important like chassis of the whole device that holds our speaker and pieces and our buttons on the back.
Then we've got the electronic guts connected to the battery holder. As we said, it's a completely analog circuit. There's no ICs or digital anything running here. And that connects to the strips of the Velostat. And the switches, the speaker, which we didn't really talk about, but this is something like you'd find in a greeting card.
Oh yeah, it is. We've got this really lovely speaker in here. It's got a really cheap plastic cone, and then what's going on right there?
That's the coil.
Cool. And so we've seen a few teardowns like this so far, but we run a current through the coil, and then there's a cheapo magnet behind here, and then that vibrates. And this whole system, this analog circuit and this cheapo coil and speaker are all tuned to work with each other. There's no like conditioning elements in between.
Right.
Hey guys, this was a really fun teardown. If we left anything out, if you have any questions, please shout at us in the comments below.
Let us know what to tear down next.
Yep, and if you would like and subscribe, that'd be pretty cool of you. All right, that's it.
Bye.
Hello friends, a reminder to like and subscribe to this channel. Definitely send some comments. Pepin is getting real thirsty, it's pretty sad. And someone send me the rest of my body.